right, good afternoon, everyone. Thank you for joining. I'm Dan Belcher. I'm one of the founders of a new startup called Mable, and this is Joe Lust, one of our engineers. First off, I want to thank you for coming. I know we're competing against lunch and a keynote with Diane Green and Jeff Dean, so you must all be as excited about testing as I am, right? Right? Yeah, okay, good, yeah, woohoo! Okay, so we're here to talk about the future of software testing and the relationship between sort of testing and GCP. And so one thing I do want to note, I am a former Googler, so I'm in recovery. I left at the beginning of last year. What it means is that I get to use the same infrastructure that I used to use when I was at Google, but now I have to pay them a lot of money for it. But I'm happy to be here. We're a very happy Google customer, as I bet many of you are. So Mable, we started that company about a year and a half ago, and we started basically with a very broad sort of approach, and we interviewed hundreds of software teams. And we would sit down and ask them basically, well, what's working well, what's not working well? And we heard a bunch of things. So we heard that, as an industry, we're moving toward continuous integration, continuous delivery, DevOps, right? Raise your hand if you have a lot of work underway to move to DevOps, CI/CD. Yeah, all right, right? So we're all going there. Raise your hand if you feel like you're done, everything's going great. Hey, 1, 2, 3, good. And so another thing that we heard was that there's an emerging sort of bottleneck in that journey, and that's around software testing. And so the thesis that we developed is actually that software testing needs to evolve if we as an industry can achieve kind of the potential of DevOps and CI/CD. Okay? And so we set out to build Mable, and this quote left a mark on me. One of the QA leaders that we spent a lot of time with very early on said, hey, Dan, let me just put it very directly. My teams are shipping features at a pace now that I can't keep up. There is just not enough time to test. Right? Does that sound familiar, I'm sure, to some of you? And so we figured out, we thought, well, how can we help him solve this, right? And what we believe is that we've reached sort of a tipping point, right, as you start to approach continuous integration, continuous delivery, where fundamentally the ways that we've thought about QA historically don't really apply anymore, right? I actually bumped into a former colleague, Marius, back there. Where's Marius? Marius, he and I were sitting in a room probably 13 years ago planning our annual release at Microsoft, right? And so we would talk about, okay, how many months, how many weeks do we need for QA for this release? And we'd work through a detailed plan, incorporating all the changes that we expected to happen to the product based on a functional spec, right? A lot of people are writing functional specs these days. Yeah, a little bit. And now we're at a point in many environments, or at least we want to get to a place where change is just continuous, right? So you can't plan for a given change anymore. It's continuous. We're talking about, an order of magnitude more releases. And so the challenge to us as an industry is how can we achieve that velocity while still having confidence that we're delivering high quality product to our end users? So this is an illustration actually of our team at Mable. So we only have, a handful of people contributing to this project, which is our UI project. And we're doing, as many as 100 commits that get pushed to production every single week, right? And this is a little team. Now imagine we're orders of magnitude, as I know many of your teams are, orders of magnitude larger, right? So think of that pace of change. How can we make sure that we're shipping high quality product? And these aren't small changes. We're talking about thousands, tens of thousands of lines of code shipping to production every single week. Right? And this is to ignore the fact that we update dependencies, configs, and so forth every single day, right? And that's all change that could lead to a broken product for users. And so the challenge to us is how do we maintain this velocity while achieving, good confidence that we can trust the product that goes out the door, right? And maintain our users' trust, based on that. And to make the challenge even greater, as QA leaders, as VPs of engineering, we are being tasked to make sure that our products work on more devices, more browsers, more resolutions, more permutations of the client experience than ever before, right? And so now you think about, that QA leader that has this pace of change that's just unbelievable coming into the sort of team, and on top of that, we're being tasked to say, let's make sure that it works across a wide variety of devices. And so some teams are struggling to say, how do I build out the infrastructure that I need to make sure that I can test effectively across all the client experiences that I have to support. And the risk is that we end up in a position where the QA sort of function or process is a bottleneck for development teams, right? And so think about all the innovation that's happened over the last 10 years, development tools and processes that enable you as an engineer to build and ship code faster. Think of all the great innovations that have happened in the DevOps space for you as a sysadmin or an operator to release that code to production and monitor it and manage it. Well, where's the innovation for QA, right? And so this is what we're focused on. And we actually believe that we're at the beginning of a new era of what we call intelligent testing. And really, this is intelligent test automation, right? And there are some principles that we believe in here. The first one is that tests have to be able to adapt to change. And what that means is as the product evolves, it has to be very infrequent that the tests blow up because of a change to the product that doesn't actually affect the user experience. The second principle is that we think that tests are going to be running in the cloud, right? We'll talk in a minute about how automated testing, like the execution of automated tests, is the perfect use case for cloud computing. Third, we'll talk about how the tests that get executed, the output, that we can't be in the business of reviewing the output of every test execution that goes by to confirm that there aren't issues. We need to apply analysis to that output to tell us when there are issues, right? And that's a really important shift. And then finally, this all has to happen in the context of a pipeline. We can't have QA sort of off to the side trying to inspect releases as they go through because, again, the pace is such that it has to be automatic and automated. Okay, so those are the principles, and what we'll do now is we'll explore each principle in detail and show you how it works when we integrate with GCP. GCP actually provides a really compelling foundation for solving a lot of these problems. And so the first principle was tests have to be able to adapt to change. If any of you have worked with legacy testing frameworks, you've probably struggled a little bit with tests that can sort of survive changes to your front end, for example. Anybody work with Selenium? Selenium? Yeah, okay. And anybody built great Selenium test suite that can seamlessly handle dramatic changes to the front end without false positives? Not one hand. Maybe an elbow back there. Yeah, almost. Oh, down. That was the thumbs down, right? And so one of the problems we need to solve is exactly this, to make sure that tests don't break when the user experience isn't affected. Because when you have that situation, you're trying to deploy changes to production rapidly, false positives in tests can create all sorts of dysfunction, right? Either you stop the release, creating a backup in the pipeline, or you end up with developers saying, hey, QA, your tests, those are bad tests, and QA saying, well, you broke the test, why don't you go fix it, right? Anybody been in that? We've been in that situation. I don't even have to ask. And so we created Mable just as an illustration to be intent-driven. And so what that means is we use a Chrome extension. And as a QA engineer or a product owner or a support person or anyone else, you basically use your application as you would expect end users to, and then Mable captures the intent of your actions and generates tests based on that. Right, and we'll talk about how that works in just a second. An important thing here is to look at the area in red where it says, click the close alert button, right? And so that's just a step that Mable sort of recorded as you were using the application. Now, when we run that test in the cloud, it could be that when we get to that step, so you look at the area that's highlighted in red, that button now says dismiss, right? And the XPath changed. The XPath is sort of the location of that button in the DOM, the structure of the web page. Now, historically, this would be a disaster for your tests, right? Because anything that interacted with that button would fail. What we've done with Mable is implemented a set of heuristics that say, okay, given the intent to click that button, let's go figure out how to find the button if we can't find it using the locators that we had originally. And so we've built sort of a model of that button and every element that we interact with. And so if we can't find the button where it used to be, we'll find the button using a different heuristic, and we'll make sure that the test continues to pass. And then if it does, we'll update the test. Right? And so this is an example of how you can create tests that can survive these dramatic and frequent changes in at least the front end of an application. And so Joe will talk a little bit about how we do that on GCP.
Thanks, Dan. So as Dan was saying, and as any developer here knows, the real problem with continuous testing these days is brittle tests. You check in a commit, 6,000 tests fail. So we really do need to make these tests automatically adapt. And not only do we make them automatically adapt, the system has to adapt because nobody can go through 6,000 tests to fix that CSS bug. So here at Mable is how in GCP we build a continuous, seamless adaptation workflow. We start with everything in the bottom right here, the cloud data store, which is our storage place for all of the scripts that we're going to run, all of the tests. And then these tests get loaded into our testing cluster in Kubernetes, which is going to be able to run hundreds of parallel instances of that browser. And they're all going to emit tons of observations, hundreds a second, as Dan mentioned, how we're building that model of that page, of that element. And this continuous flow goes through Cloud Pub Sub and into Cloud Data Flow, where we can do continuous stream processing and transforms on this data. And we can determine, did something odd happen? Did we not find the button? Did it change its text, but we think we know where it really is? And in some cases, we might not know where it is. In that case, we would go out to Cloud Functions. We can call a script, send a Slack message, let our user know that something has gone wrong. But in most cases, we can actually start closing this loop. We can figure out that dismiss is actually the correct button, and we can automatically change that script and say, this is the button you need to click. And we can feed back into our data store, we can update that script, and the next time we run, we know exactly where it is, and we don't have to adapt again. The test has been healed. And by doing this continuous flow, we seamlessly adapt and are able to achieve continuous testing.
Great. Thank you very much, Joe. And so that's a general pattern for how we can create tests that survive despite changes to the structure of the underlying page. So practically speaking, what this means is that for our users, putting a maintenance message at the top of the page that changes the DOM and the XPaths of all the elements on the page doesn't break the tests, right? Changing the IDs of elements doesn't break the test. Changing the CSS classes don't break the test, right? And so that makes it so that you don't have a lot of noise around, sort of maintaining the tests as part of the pipeline. So that's the first principle. Second principle, tests will run in the cloud. We predict that 3 years from now, we're sitting here talking, and if I ask how many people are building out big farms of test infrastructure for on-premise, we think very few hands are going to go up. And really that's because, as I mentioned before, testing is a great use case for cloud infrastructure. It's a much more efficient way to run tests. And so let's just talk some numbers here. So imagine your web application, you only had 50 test cases or scripts that you want to run, right? I'm sure many of you have orders of magnitude more than that, but let's start small. So 50 things. Let's say I want to add some items to a cart. I want to check out. Let me search. Let me sign up, register, so on and so forth, like the core of a web application. Now, let's imagine that for each of those, you only want to test, on average, 3 scenarios. So users with different permissions or in different locations or different credit card numbers and so forth. So let's say just 3. Now, you want to support probably the 4 major browsers, let's say, and maybe the current version and 1 previous version, so 8 browser versions. And then you have 3 environments, so you deploy to QA and then staging and then prod, and you want to test every time you deploy. And then you do 3 releases a day, right? Which may sound like, oh my God, that's an incredible velocity to many of you. And then to some others, you'd say, well, you mean just me, not my whole team, right? And so, but in this world where you're deploying about once every 8 hours, you're talking about nearly 11,000 tests being executed a day, right? So this is real volume generated from trying to get decent coverage across only 50 tests. Okay. Now, if you wanted to look at let's say we ran, we created tests that run pretty quickly, 7 minutes each on average. You're talking about nearly 1,300 compute hours dedicated to executing these tests, and you're talking about a very simple sort of test suite and set of scenarios, right? So this is real infrastructure that we need to deal with. Where it gets kind of crazy is when you think about the concurrency that's required in order to execute those tests within sort of target windows. So if you're doing a release every 8 hours, and you want to run those tests that we talked about on the prior slide, then sure, if you had 54 nodes of compute executing tests in parallel, you could churn through them in about 8 hours, so before you do your next release. Not too bad. Now, Joe doesn't like to sit around for 8 hours after he does a deployment to wait to find out if the test's passed. In fact, he wouldn't even tolerate an hour, but if it was an hour, we would need about 420 nodes of compute to be able to run all those tests within an hour after the deployment. Okay? Now, what we expect, and what I think many of you expect when we get to that sort of vision of continuous delivery, is that we're talking about minutes to execute the entire test suite, because you want your engineers to be able to get that code in production and move on to the next task and not deal with a bunch of work in progress. And so here we're talking about 3,600 nodes of compute to execute those 50 simple scripts, right, for this application, right? But the reason why this is a perfect use case for cloud computing is because for how long do you need those 3,600 nodes of compute? The line in green here, you need them for about 10 minutes, right? And so why would you deal with provisioned capacity to execute those tests? You want to burst, run the tests, and then make it disappear. And the efficiency is basically the entire chart, right? Because you're only paying for the green spikes, you're not paying for the rest. That's the most efficient model for executing those tests. And we can show you exactly how to do it.
Thanks, Dan. So let's say you're on the bandwagon, you want to build your cloud-centric, scalable Selenium testing framework. Well, lucky for you, Google Cloud Platform has Google Kubernetes Engine. Now, I need to give you a disclaimer. This won't let you test everything. Some browsers are limited by their architectures or licenses, like Internet Explorer, Safari on Mac, iOS, and Android. But excluding those, you can still run a very robust setup in the cloud. So, for example, you could use Selenium Docker project images of Firefox and Chrome and schedule them on your Google Kubernetes Engine instances as pods. And Kubernetes now is automatically going to find a home for each one of those pods. It's going to start stacking them up in instances. It's going to efficiently pack them. And if it can't find a home, add more instances. And keep adding instances until it can run all those tests, all 10,000, for example. But then, when they're done, it's going to start getting rid of nodes, scale all the way back down to 0. This makes it highly efficient, highly cost-effective, and it's actually all very much no ops. It just works. So at Mable, for example, we have many such Kubernetes clusters, but last year we set up one of them, and to date it's run about 12 million containers, and it really hasn't been touched in a year. It automatically gets upgraded, automatically maintained. It's a very, very robust setup. We like to think about Ron Popeil when we look at our cluster. We just say, set it and forget it. Now, again, using these tools, you're easily able to take your Selenium infrastructure and just seamlessly scale it in the cloud.
Great. So what Joe will show us next is how we've implemented that in Mable. So imagine you didn't want to provision your own Kubernetes architecture and deal with the scheduling and execution and all that yourself. If you were to use Mable, let's show them how that would work in real time if we could bring up the demo.
Sure. So what we have right here now is an example of what we call a test plan in Mable. In this case, we're just going to kick it off, hitting the run button. And what's just happened is our pods, as you can see here, for Chrome and for Firefox, have been sent off to be scheduled on the Kubernetes cluster. Actual browsers are being spun up, and then we actually here have our different tests. So for example, we have find a shirt, and we can see in this case we're going to go to Nordstrom, we're going to look for men's shirts, and we're going to assert that we found the proper shirt. And what's going to happen is that Mable is going to make all those permutations. It's going to make 2 tests, 2 browsers, so 4 containers are going to spin up. And we can see them all right here. Looks like they took off about 30 seconds ago, all running in parallel. And what's going to happen is Mabel's making all those observations we showed you earlier, taking all the screenshots, learning everything she can about this given application under test, taking screenshots, and letting us do all of this just in parallel, much more scalable than anything you generally would be able to find when you're running your own setup. And here we are. We've already gone through. We started finding pants, and we are scaling very well in the cloud. You have the slides, Ken?
Thank you, Joe. And so that's what we're talking about when we talk about tests being the sort of automated testing being the ideal workload for cloud computing. Right? We can, kick off a test, fan out, run that test in parallel, turn the resources off, and only pay for the resources for that very short period of time that we needed them to execute the test. You also noticed it's the anniversary sale at Nordstrom here. So the third principle, test results need to be more insightful. And so the core there is, as we're executing tens of thousands of tests over a given release cycle, a quarter or year, we can't be dealing with each test run as a special snowflake, right? Joe would never go into an application and look at those logs of the test to make sure that it's running effectively. What he needs to know is, did I break the product, right? And otherwise, he's going to be on to the next feature that he's working on. And so how do we do that? Well, one principle for us with making test results insightful is we think, what would Mable as a persona do, right? If Mable was a manual tester, would Mable only look at, sort of the HTML of the page, and is the HTML doing what it's supposed to do? Probably not. Would Mable only look at the screenshots and see if the screenshots were appropriate? Probably not, right? Mable would want to look at a variety of sort of aspects of quality of the application and then decide whether, it works or not based on those. Right? And so what we've done is built a pipeline that can capture all these different types of data. We feed that data into an analytics pipeline, and then we generate insights based on either heuristics or models that we've implemented to detect when the application's not performing as we expected that it should. And so here is a good example. We have some very simple insights, right? We can use basic heuristics. Many of you could build this one, where we attempt to click on every link in an application, and we have heuristics that says, if there's a new broken link, why don't we tell Joe about it and say, your last build actually broke some links, right? Simple stuff. The next one, client-side JavaScript errors. So we'll capture client-side JavaScript errors, associate them with each step in the test, and the important thing here is letting people know when there's a change versus the model or state that we have of the page, right? So many of you probably have lots of client-side JavaScript errors when we load the app that don't actually hurt the end user, right? And so we're not going to tell you again and again and again, we saw again in this test, wake up at 3 o'clock in the morning because you have some errors, right? But what you might want to know is when I just did a deployment that on step 4, there are new errors, right? And so this gives you a way of preventing, technical debt from accruing with these errors. And so these are 2 heuristics-driven insights that this pipeline gives us. Another one, model-driven insights around anomalies. So think of timing, right? So Mable, as a manual QA engineer, would probably love to be able to detect subtle changes in page load time or test execution time, right? But that's a challenging thing for us to do as humans, right? Running test after test, unless you have a stopwatch, right? But you're not, in control of all of your actions. So what Mable will do is captures timing information, page load time, test execution time, step time, and so forth, and then predicts how long it will take the next time we run a test. And if the actual observation is different than the prediction, then we surface an insight. Okay? And of course, Google Cloud and machine learning play an important part in that. The feature that people are perhaps most excited about right now with this is detecting visual anomalies. And so our Nordstrom colleagues in the audience will appreciate this one. When we search for those pants, we started the test a couple days ago. It was the preview of the anniversary sale, right? And then A couple days later, we ran the test, and the anniversary sale had been launched. And so what changed? You can barely see it, but the menus at the top changed. And that was the first time Mable had ever seen those menus changed. And so she flagged it as an anomaly, right? As an anomalous change. Now, what you can't really see, you could barely see here, is when I run that search for women's pants, the order of the pants change every time you run the test, right? There's a random aspect to how those load. And so Mable has to be smart enough to detect expected changes from unexpected changes. And so the model actually takes these dynamic areas and says, well, these are dynamic regions. I'm not going to surface visual anomalies in those regions because they change too frequently, whereas there are these other regions that are predictably the same every time I run the test, and if I see those change, then I'll surface that as an insight. And so these are the type of insights that we're trying to drive toward in this new era, where we're giving you actionable, relevant information so that then you can dive in when there are potential issues. But it takes a lot of work. Thankfully, we have some infrastructure that we can rely on.
Thanks, Dan. So as Dan points out, one of these major limiting factors we have with tests in general is that they make a lot of noise. As a developer, the last thing you want is yet another report. Here's 6,000 things you need to fix right now. So what comes out of this process has to be insightful. But also, like in Mable, when we're running on scale in GCP, we have to handle tons and tons of inputs and figure out which ones of those are insights. And more importantly, we have to tune them down to the exact insight for that specific customer, whether it's insightful to them. So we start, as you saw earlier, with our Kubernetes engine, which is churning through thousands of web pages, making our continuous feed of observations coming out, and then we feed it into several different pipelines. The first pipeline is our continuous prediction pipeline. Here, we harness Cloud Data Flow, again, to work on the data, transform it as necessary, and we feed it into Cloud ML. And in the Cloud Machine Learning, we run our models against, for example, those images, or against timing, and we decide, did this change? Is this a visual anomaly? Or did this get too slow or too fast? And if that is the case, then we immediately push via PubSub to Cloud Functions so we can notify our user. We want to do that immediately, so it's a timely insight. And that, for example, is sent out over Slack. So within about a second or two from hitting that URL, observing, we popped up a message in your Slack saying, we found something is going way, way too slow. Yes or no, is this good? But we can't just tell you that. We want to take that feedback back into the machine, because the machine needs to understand what's important to you. So in this case, Cloud Functions lets us have an endpoint that takes that Slack feedback back in when you click on the, yes, this is a good insight, or no, it's not. And we feed that back into another pipeline, our continuous training pipeline. We can do a little bit of cleanup, for example, in Cloud Data Flow. And then, again, by Cloud Machine Learning, we can update that model, make it adapt to you, and tune your insights. We won't give you an insight that's not insightful to you in the future. We put this back into Cloud Data Store, and that data store is the reference of all of these models, so we now have a circle, and we are continuously training and predicting and training. Another limiting factor sometimes with creating these sorts of insights is maybe you have a new model, and we need to change that model. We need to maybe go back to 100 million pictures and retrain against all of them. That can be very prohibitive from a scaling standpoint, but using, for example, Kubernetes engine, we can take a brand new Python ML script. We can, as we did at Mable this week, spin up 400 machines, crush all of those millions of images, update everybody's models, and now we have been able to push something out that would have been very challenging previously back into our continuous prediction and training pipeline. All this being perfectly serverless, each one of these components able to scale up and down independently with no ops on us, all through using these different serverless technologies in Google Cloud.
Thanks, Joe. So if you wanted to build this, you just do this, right? It's not that hard. I mean, I think the staggering thing for me is to think about where we are as an industry today. And while this has taken some work to build, right? Great team, PhDs, like making this stuff happen. Imagine what it would have taken 10 years ago, right? Where none of these services existed, or at least were available to us publicly outside of Google. And so it's actually making it possible to solve some problems in a very elegant way that weren't really possible to solve before unless you were running at incredible scale, right? Google scale or what have you. And so that was the third principle, right? that test results need to be more insightful. And then the final one is testing then needs to be part of a continuous delivery pipeline, right? So QA can't be sort of off to the side. It needs to be fully automated, part of the pipeline. And what a pipeline might look like is something like this, right? Joe will write some code. He'll commit it. We'll do a build, execute some unit tests. Once that's ready to go, we'll deploy to a QA environment. That deployment triggers some tests. Once those all pass, then we promote that build to staging environment or deploy to staging environment. And then we run some tests on staging. If those pass, we deploy to prod, and then we'll do some final smoke tests in prod. So let's see what that looks like at scale.
So as a quick overview of the demo we're going to do, we're going to show you how we can create continuous testing and continuous deployment workflows tied together to get us a testing feedback loop. In this case, we have a code commit, perhaps to GitHub. That can then trigger a deployment trigger in Cloud Build, which is going to automatically go get our code from Git. It's going to build it, deploy it, tell Mable there's a new deployment available via its API. That will then come back and test our app. And if it's successful, it can call back to Cloud Build and keep propagating through our deploy, test, deploy, test, deploy, test cycle. So to show you what that looks like, if we could please get the demo laptop. The first thing we need is an app, because we have to deploy something for our continuous deployment. So in this case, we have calc.mable.com, a very primitive calculator where we can do things like addition. Now, this demo is going to start like all great code deployments start with a merge. So we have our live lucky demo PR. Let's hope this works. Do it. OK. So now we've just sent this off into the ether, and we're going to be triggering Cloud Build. And Cloud Build should take over now, and it's discovered that we have just started the deployment. And this lets us do a simple workflow. For example, we're going to install our application's dependencies. We're going to build that web app. We're going to push it out to Google Cloud Storage for static hosting. It's actually going to give us a dynamic URL. And then we're going to call Mable's deployment event API and feed in that dynamic URL so we can actually run that test against any different location. If we see there, it looks like it's almost done building our web app. But let's talk about what it's actually going to do. So we've got some more tests here, because again, for continuous testing, we're going to need some tests. And in this case, similar to before, we're going to run across multiple browsers, Chrome and Firefox, and we're going to do a simple mathematics test, because we need to make sure the math works inside that calculator we built. And so we have some simple test steps here. For example, we want to make sure that 3 plus 3 equals 6. That's a pretty good invariant. Hopefully it holds. But that's only one test, and a calculator could do many things. So we actually have another feature we're going to use. Oops, let's see. And that's called parameterized testing, because we don't want to write tons and tons of different tests. So here we have something we call a data table. So we have 50 different permutations, and now we can test things like multiplication, division, subtraction, negative numbers. And now we're getting 100 tests, and all we had to do was write one test. So given all that, thank you. This feature is live, by the way. So given all of that, now Mable has already started, and our servers are spinning up. Here they go, off to the races. 81, we should get to 100 here shortly. A little bit of a burst. But again, what's going on? All these separate containers are spinning up. We have 100 instances pumping in Google Cloud that just turned on for Firefox, for Chrome, and they're running all of our tests in parallel, and it looks like they're done now. So that took under 2 minutes, I believe. And in a classic environment, that would have taken 3 hours. And all of it was driven, this continuous testing, continuous deployment, by you making a single commit.
Woo! All right. So, thank you, Joe. So we've talked through the 4 principles that we've been focused on that we think will sort of underlie this new era of intelligent testing. I know that if you work in the QA space, there's been some struggle lately keeping up with the pace of development. The good news is there is hope right? We're going to, as an industry, find a way to deliver tests that adapt seamlessly to applications that change rapidly. We're going to run those tests in the cloud at scale and speed that we haven't seen before, as Joe's demo just showed us. We'll have insights based on output that are actionable, so we don't have to deal with the individual results of every test. And then also, we'll integrate deeply into automated pipelines so that we don't have to have manual intervention at every step in a release process. And it's all powered by innovations in cloud computing and, here, in our case, in Google Cloud. And so thank you very much for your time and attention. We're here to answer any questions that you might have.
Thanks.